I bought a new power supply. It's a Siglent SPD3303C linear power supply with 3 channels. 2 of them, channels 1 and 2, are fully adjustable between 0 and 32 volts and can have current limits between 0 and 3.2 amps. And then there's a third channel, which operates only at 2.5, 3.3, and 5 volts at 3.2 amps. It can't be current limited. This is a basic and ordinary bench supply. So why am I making this video? It's because I want to explore its behavior when I first enable a channel. How fast does the voltage rise? What is the shape of the curve? This supply surprised me a little with some discontinuity. I'd be interested to know the behavior of your power supply in this regard. Please leave comments below. Next, let's take a quick look at this power supply in action. Let's turn it on. So now you can see the display is showing the output or the settings of channels 1 and 2, the fully adjustable ones. And then if I press this button down here, that actually enables channel 1. And the multimeter shows that when set to 3.3 volts, it's actually producing 3.301, which is pretty close, so pretty good. And then if I adjust this dial here, I can change the voltage output. So we'll make it, say, 5 volts. And there we are, so showing 5.02. And so that's good. And then if I press this button marked fine, I can change it by a smaller amount. Like let's try changing it to 5.01, which it does. So the fine control can be used with either volts or amps, and in particular this amp setting controls the current limiting. And so since the channel is enabled right now, it's showing just the negligible current draw from the multimeter. But if I start moving this up and down, it changes the current limit. And I can also do that by disabling the channel by pressing this on-off button. And now it shows the current limit setting all the time. So that can be a little bit easier. And then the fine control works for the current limiting as well. So that's all pretty nice. And channel 2 works the same way. If you just select it, then the knob is controlling what's going on with channel 2. The third channel, the voltage output, is from this slider switch. So that's 2.5, 3.3, and 5. And like I said, there's no current control. I bought this power supply to replace this old one that I built from a kit so many years ago that I really should be looking at replacing its capacitors. It's much more convenient having a power supply that shows me the voltages and lets me adjust them without using a multimeter. I bought the C model from the Siglent 3000 series basically because it's the cheapest. It was nice to save more than $100. The XE has a better display and the X is more accurate, but I didn't think I needed those things. All 3 of these are actually controllable from an application that you can run on Windows, an application that you get from Siglent. But curiously, to make that work, you also have to install a package from National Instruments called NI Visa. Now, let's look at the power supply's behavior when a channel is first enabled. We connect an 8.4 ohm resistor as the load, and notice that the power supply is set to output 8.4 volts, and we're seeing 1.02 amps. So the power supply is correctly measuring the current. So the next thing we'll do is use an oscilloscope to look at the output signal from the power supply when the output is just first enabled, and we'll do that using single trigger mode. And here we go. I'll set the scope into single trigger mode and then reach over and enable the power supply. And we see what happens with the power supply output when it's first enabled. So let me turn on some cursors. And we see 2 things. And one is a sort of jagged discontinuity right at the beginning, right when the power supply is first enabled. Then we also see that it takes about 9.5 milliseconds for the output to come close to its full output value of 8.4 volts. Let's try this again at 4 volts. So we'll disable the power supply, drop to 4 volts, and maybe we'll change the vertical scale of the scope, single trigger, and enable. And we see a very similar pattern. I've adjusted the oscilloscope to let us take a better look at the discontinuity. So I'll reach over and enable the supply and turn on some cursors. And we can see that the time of the discontinuity is about 74 microseconds. and the change in voltage is about 312 millivolts. Let's adjust the current limit and see if anything changes. So I'll disable the supply, go to amps, and maybe set this to 2 amps instead, or 1.9, good enough. And we'll enable again. Oh, single trigger mode, enable again. And we can see that changing the current limit didn't make any difference. And here's a capture at 10 volts, 3.3 volts. Here's a capture at 2 volts. And finally, here's a capture at 1 volt. And so we can see that the shape of the curve does vary a little bit with the voltage levels, but doesn't appear to depend on the current limit settings. I'd be interested to know if other bench power supplies exhibit similar behaviors, both the discontinuity at the beginning and the amount of time it takes for the output voltage to rise to near its set point. And the reason for that is that some devices can care about such things. So if you have a bench supply and have made measurements like this or can, I'd be very interested to know the results. So please leave comments. As a final bonus, here's a capture of the 5-volt channel on my old power supply. So you can see that it takes less than 2 milliseconds to get to full voltage, and also there's some noise from the mains power supply switch. Keep in mind that this power supply does not have an enable button. I think I'll end this video here. Thanks for watching, and please comment below.